Okay, thank you. Okay, so today the introduction part. Normally, there's an introduction to the webinar. Patnaik sir will be joining very soon. Until then, I will start with the presentation. Then we can make the introduction probably later on. Today we are going to discuss about an interesting subject, which is probably for the first time most of you are listening. This is challenges in prosumer electrical installation. Let me share the screen. Yeah. I'm sure you are able to see the screen properly. Also, let me switch off my camera. So today we are going to discuss about the challenges in distribution and the safety at prosumer premises. As all of you are aware, nowadays we are no more consumer but prosumer. Prosumer means a person who is producing as well as consuming electricity. If we look at the definition of prosumer, prosumer is an entity or a party which can be both a producer and a consumer of electrical energy. This is the definition of prosumer, because consumer means who is only consuming electricity. Prosumer means a person or an entity who is producing and consuming electricity. Similarly, if you look at prosumer's electrical installation, please note that we are talking about low voltage electrical installation, means up to 1000 volt AC or 1500 volt DC. Low voltage electrical installation connected or not connected to a public distribution network, able to operate with the local power supply and or with local storage unit. This is the prosumer electrical installation, and that monitors and controls the energy from the connected source, delivering it to current using equipment, local storage unit, public distribution network. So if we look at consumer premise, or in comparison to the consumer premise, prosumer premise need monitoring because we are talking about smart grid as well. So this is a low voltage electrical installation, which is either connected to a public distribution network or not connected to a public distribution network, with the local power supplies and or with the local energy storage. Probably there is a storage battery system as well. And it is having a monitoring and control system for controlling the generation, controlling the storage, controlling the pumping of the energy, and so on. And these prosumer electrical installations are classified into the individual PEI, collective PEI, and shared PEI. Now, the mode of operation. There is a direct feeding mode, means the energy operating mode in which the public network supplies to the PEI. That means the energy is coming from the distribution DSO, distributor's facility to the PEI. Reverse feeding mode means operating mode in which the PEI supplies to the public network. So it is feeding back the energy to the network. Connected mode means operating mode which need connection to the public network, direct feeding and reverse feeding mode. So in a connected mode, the PEI can directly feed or the DSO can directly feed to the PEI, or PEI can reverse feed the power energy to the DSO. So in connected mode, whereas in island mode, operating mode in which the PEI is disconnected from the public distribution network but remains energized. That means the localized source is energizing that particular part of the prosumer electrical installation, and the system is working without the energy, without a connection to the distribution network. So two modes, connected mode and islanding mode. Also, important to understand individual PEA, collective PEA, and shared PEA, connected mode as well as islanding mode. Now, smart grid and electrical installations interact each other because the idea is to use the energy optimum in a very good way. A dynamic power demand response concept should be implemented. A smart grid has an impact on electrical installation in the following aspect: the consideration of users' need, taking into account the constraint of the public network, because the system, the smart grid, so we are talking about IoT based or the smart system, it should consider the user's need with respect to the time of the day, with respect to the demand for each of the time. That means the entire consumer's requirement can be fed into the system, and the system considers, so the smart grid consider that, for example, at morning 9 o'clock, this consumer need, let us say, 2 kilowatt, or maybe in the evening, afternoon, maybe 0.5 kilowatt, evening, maybe 6 kilowatt, something like that. So the consideration of the user's need and consider can be fed into the system, and the system, the smart grid, will work in such a way that it takes into account the constraints in the public network. The design and configuration of the installation that shall allow load shedding and the source selection by electrical energy monitoring system. The user should be able to give different inputs to electrical energy management system depending upon the contract with the DSO. DSO stands for the distribution system operator. That means the distribution company. So both the electrical, the programs or the smart grid or software or the automation system plays a vital role in prosumer electrical installation, because we are talking about utilizing the energy optimum and not wasting it. The consumption and production of energy from renewable sources such as PV or wind turbine are intermittent, and it is suggested to install storage capacity within the prosumer electrical installation if availability in island mode or isolated mode is needed, or to maximize the self-consumption in connected mode. So basically, battery storage, localized battery storage is also promoted, also a need depending upon your requirement. Now, if we look at these wordings, I copied from the IEC standard. If we look at the word, say, for example, the consumption and production of energy from renewable sources such as PV or wind turbine are intermittent. I tell you an example, not related to low voltage prosumer installation, but related to wind turbines. Wind turbines operate or generate electricity based on the availability of the wind. And the availability of the wind varies depending upon the time. For example, morning 9 o'clock, it is 10 meter per hour. Maybe during the lunch time, it's only 3 meter per hour. Then the afternoon, maybe another, it may be 8 meter per hour. During night, maybe 12 meter per hour. It keep on varying depending upon various factors. So, say for example, in Tamil Nadu, during 2010, 2011, and 2013, the total installed capacity of wind turbines were much more. Say, for example, 7,000-8,000 megawatt of wind turbines, but the grid capacity was quite less. As a result, there were a lot of challenges. So the wind mills were forced to switch off in order to manage the situation. But later, the government implemented, or some private agencies implemented, a wind monitoring system or wind prediction system. So the available wind at every time of the day is predicted well in advance. As a result, the distribution company or the transmission company, they were able to allocate sufficient grid for taking up or to absorb this particular energy. A similar system also will happen with respect to the low voltage electrical PEI, prosumers electrical installation. Now you are seeing the architecture of a PEI. So here you can see number one is the public electricity distribution, the transformer of the distribution company. Number 12 is the point of commencement of supply or origin of installation, which we say. We have the solar PV. installation. You can see the direction of electricity flow here. We have probably there is a micro wind, the electricity direction is also shown. Probably there is a localized generator as well, which is feeding to the prosumer electrical installation. This entire 13 or this dotted line, this is the prosumer's electrical installation, or let us say local distribution. Then there is an energy storage device. Current using equipment, if we look, we have the home appliances such as the TV, fridge, TV, fridge, and washing machine, dishwashers, and so on. It may be motors, lightings, and heating system. Also, maybe car charging unit. Now, if you look at the symbol of the car charging unit, you can see here the energy is bidirectional. Also, for the storage battery, it is bidirectional. So one of the new concept is the battery, the available battery in the car also can be used as a source of energy. It can be utilized as a source of energy. The energy can be stored, and in emergency it can be used. Now the entire system is controlled by electrical energy management system. The entire system, the demand, as I said, the consumer is able to feed his energy demand based on the time. As a result, the available power from the distribution company can be programmed according to the availability. Probably some energy or a majority of the energy is saved in the localized energy available, the storage system, and so on. So basically, electrical energy management system plays a vital role in this particular case. This is the architecture of an individual PEI. Individual PEI means one prosumer electrical installation. You can see here the distribution company's transformer. This complete box means this is the prosumer electrical installation. Point number 8 is the origin of installation, means the meter board of the distribution company. Number 2, this is a power supply, probably making electricity. And 3 to 4, 3, 1, 3, 2, 3, 3, 4. These are the different kind of load which is used in a building. Number 4 is a storage unit. Number 10 is the electricity energy management system. And you can find different kind of monitoring systems, energy meters or measuring equipment, and the direction of current. So typically, the architecture of an individual prosumer electrical installation looks like this. So there are different type of PEI. The first one is individual PEI. Second one is collective PEI. In this case, it's a collective PEI using distribution company's distribution system, DSO's distribution system. That means there is a transformer, and the distribution company is the black line indicates that the distribution system is owned by the DSO. And here there are different buildings, different prosumer installations. So 51, 52, 53 are the different prosumer installations, and number 6 is a generating station. So this is an example of a collective prosumer electrical installation. The different power supplies may supply all involved prosumers through either the distribution system within the PEI or DSO or distribution system if agreed by DSO. All electrical installations are considered as consumers. One separate unit producing electrical energy is managed for the community for consumers. For example, 51 to 53 are consumers, and there is a common generation. But the whole installation can be assumed or can be considered as a prosumer electrical installation or a collective prosumer electrical installation if the energy distribution company agrees. This is a collective prosumer PEI with the distribution system within the prosumer electrical installation. So here you see the transformer. The point of commencement of supply is at a common point. The entire houses or the entire apartments or whatever is connected. Here 51, 52, 53 are the consumer numbers, maybe 1, 2, 3, 4, and 3, 1, 2, 3, 3 are load. Number 2 and number 4 are probably the power supply as well as the energy storage system. So this kind of a system, for example, if we look at apartment. So multiple users and one generation and storage system. This is called as a collective prosumer electrical installation with a distribution system within the PEI. Because the distribution is the responsibility of the prosumer electrical installation. The whole distribution system, this dotted line, it belongs to the prosumer. It doesn't belongs to the distribution company. So collective PEI with the distribution system within PEI in parallel with the distribution system operators distribution system. For example, this is another idea or another concept where you have the distribution system, the transformer. Each of the consumer premise, there is an electricity supply. You can see here 51, 52, 53. These are the consumer premise. Electricity supplies are there. Load using equipment 31, 32, 33. These are also getting electricity from a parallel generation. So number 2 stands for, let's say, a solar PV and a battery system. They are also feeding power to the load parallelly. So the load or each consumer may be getting a supply from the distribution company as well as from the localized generation. This is also called as collective PEI. The condition is for collective PEI in this particular case, each electrical installation is considered as a consumer unit, while a common set of local production is considered as a producer unit. Consumer and producers shall be considered as separate. So these are, sometime once when we talk about the revenues and billing and other confusions or confusing subjects, most often the distribution companies will take these kind of, different measures or different methods they can adopt. Shared PEI. Shared PEI, you can see here the transformer, the distribution system, the black dotted line, it belongs to the DSO, distribution company's network. 7.1 to 7.3 are prosumer electrical installation, not consumer. Here, each prosumer installation consists of a generation, an usage of electricity, a load, and a battery. 2 stands for generator, 3 stands for a load, and 4 stands for a storage unit. So each of this prosumer, each of this 71723 is a prosumer electrical installation. So this is called as shared prosumer electrical installation using DSO distribution system. Each building have renewable energy power source which can either supply to the building or to a group of building. Here, shared in the sense, probably one house have enough storage in the battery and he may be able to feed the power to his neighbor. Even though it is used or it is running through the DSO, arrangements will be made or considered that one house is supplying to the next house. Shared PEI, where the distribution system within the PEI is taken care by the prosumer itself. This is another concept. That means the meter, the point of commencement of supply is at a common place. So whatever the electricity generated and consumed within the prosumer installation is under the freedom of this prosumer. Origin of the PEI for each prosumer correspond to the entrance of individual system. Also similarly, shared PEI with a DSO supply into each prosumer installation with a parallel generation and storage. So this is another concept which is called as shared PEI with the distribution system within PEI parallel with the DSO's distribution system. So like this, there are different concepts, different methods. It can be an individual customer, it can be a shared customer, and so on. Why I am explaining this is PEI may be operating in islanding mode as well as, or maybe it is also operating in the connected mode. Once when it comes to the islanding mode, say for example, imagine the power supply has gone, there is no power supply. Then probably the situation of all these houses, all these PEI may be in a different situation when it is connected to PEI. I have some pictures I will show you, then you will be able to understand this. Electrical energy management system plays a very important role in PEI. An electrical energy management system shall monitor and control the operation of all power supplies, the load of the storage unit, and the operation of load. The concept and the design architecture of PEI mainly depends on the concept of electrical energy management system. The objective of electrical energy management system is to control the connection of PEI to the smart grid, to manage locally the electricity, the energy production, to manage the energy consumption. So the localized energy production, the energy consumption is managed by the electrical energy management system, and to manage the energy procurement from the distribution company's distribution system. The examples of function handled by the energy management system is power source and load management, multi-source connection management, propose load control, load shedding or load shifting, shifting from one place to another, one load to the other, or load shedding for certain areas, bidirectional exchange of information within the DSO, backup system management by means of energy storage units and power source, control the energy flow from and to energy storage, monitor the voltage quality, provide interface with the end user. So basically, the entire system control is managed by the electrical energy management system. The EEMS may be installed as a separate equipment or in different equipment or may be integrated in other existing equipment. So this background I gave you just to give you some introduction of what exactly we are going to talk. We are talking about prosumers electrical installation, which may be working in a connected mode, which may be pumping energy to the grid or getting energy from the grid. It may be working on islanding mode. It may be an individual PEI. It may be a collective PEI. It can be a shared PEI and so on. So different configurations are there. All these configurations and finally the usage as well as generation is completely controlled by the EEMS, electrical energy management system. Now let me go to the seriousness of the system. I take the example of solar PV. Solar PV, several times we discussed about the double insulation on the DC side of the solar PV. Now in solar PV, protection against the thermal effect can be achieved by three different techniques. Technique number one, you can find this information in the National Electrical Code of India as well as in several of the standards. The first technique is non-separated PV system. Here, separated means electrically separated, whether the AC and DC system are electrically separated or not. So the first one is non-separated PV system. PV array is connected to an intentionally earth referenced system through a power conversion. PCE stands for power conversion equipment without at least simple separation. This is the first option. Second option, functionally earthed PV system. In this case, PV array has one conductor intentionally connected to the earth for the purpose other than safety, by means not complying with the requirements for protective bonding. Number three, non-earth referenced PV system. It's like an IT system, unearthed, no reference to the earth. So there are three type of PV categories or PV systems are there in order to achieve thermal effect. That means in order to protect it from catching fire. Example. What you are seeing is a functionally earthed system with current monitoring on the functionally earthed conductor. I explained this picture a little bit in depth. You can see here a PV array. Don't look at the red color line, PV array. Then you have the positive and negative going to the inverter. Now AC side, this is the DC side of the inverter. AC side of the inverter is connected to a transformer. Then it goes to the AC mains. Now, transformer separated means the transformer is electrically separating the DC side from the AC mains. Now you see the transformer three-phase goes to the AC side of the inverter. Then without electrical separation, the transformer AC side is connected to the DC side. Now, one of the line, maybe either AC or DC, is functionally earthed. Generally, it is made within the inverter. Functionally earthed in the sense This connection means, let us say, for example, negative. Negative is connected to the body or to the protective conductor of the installation. For example, through a fuse. This is a fuse. The purpose of the fuse is, imagine there is a fault, and once when the fault current has to return back. This is the fault return path. You can see the fault return path in the red color line. Once when the fault current is more than certain level, the fuse is supposed to disconnect the fault. So the fuse is the disconnecting the fault current. The fault still exists. That means the inverter identified that there is a fault exists. Then the inverter, but the fault current is eliminated by disconnecting this particular fuse. Then the inverter can decide whether to continue the operation of generation, or the entire system need to be shut down. This is one method. In the same case, you can see here, there is a reference switch, there is a functional switch. An overcurrent protective device will directly interrupt the fault current, or a current sensor will control able to open the relay KFE or KPV to interrupt the fault current. So the current is monitored here, and the monitoring, you can either disconnect the relay KEFE or KPV. If you disconnect KPV, the whole system is off, no more generation. If KFE is disconnected, of course, generation may continue. It depends on the whole concept of the system. Now, it is a condition that before commencing operation of each day, the control system opens a relay KFE and close relay KPV to allow the insulation monitor to measure the PV array insulation resistance RISO. Very important. The inverter, this part, the functional earthing is a part of the inverter. Every day the inverter opens this connection. The relay is where I'm moving the cursor is opened. The contactor is on. That means the entire PV system is connected. Then the insulation resistance between the positive to earth and the negative to earth are measured. And the insulation resistance shall satisfy certain value. This is carried out on a daily basis. This is functionally earthed system. Now, most of the PV inverters which we use in our system doesn't have electrical separation. That means they are inverterless. There is no inverter, or sorry, they are transformerless. Sorry, not inverterless, transformerless. There is no electrical separation. There is no transformer inside. In that case, you can see here, there is a PV array. The negative is connected, the positive is connected to the AC mains. Now you see here the AC mains, the transformer star point is connected to earth. It's an earth system. The idea is, in case of a fault on the DC side, this is the earth fault of the DC, the current will return to the system through the route which is shown here. So the current is flowing in this fashion. Now, the current, the leakage or the fault current can be measured by putting a residual current monitoring system at the DC side of the installation. Then the inverter can decide what to do. If the current is more than certain limit, probably the KAC, the relay, can be open. As a result, the entire system can be shut down. The fault current IEF returns to PV through the AC mains earth to neutral, back through the inverter to PV negative, and through the residual current detector. As the inverter current of PV plus and PV negative are equal and opposite, the presence of earth fault current causes an unbalance detected by the residual current monitor. So basically, whatever I explained is also typed here. So in case of any fault, the fault, especially earth fault, the fault is detected in this particular case. But please note that the AC side, there is no electrical separation between the mains and the AC of the inverter. So the neutral earthing of the transformer plays a major role, because this is the fault return path in this particular case. Similarly, the same case where the residual current is monitored at the AC side of the inverter. In this case also, whenever there is a fault, and once when the fault current is more than certain level, the relay detects it. It can decide whether to open the relay KAC or close the relay KAC. That means whether to operate the system or shut down the system. And this is one of the fault protective measures. Now, every day, the device, the insulation monitor, for example, every day the inverter before starting the operation, it is supposed to check whether the insulation resistance is in place or not. Now the challenge. So whatever these three examples which I have shown, like this, we can define several examples. These mandatory requirements, for example, measuring the residual current, operating the relay, daily basis monitoring the insulation resistance. These are mandatory safety requirements. Sometimes the engineers, those who are installing the solar PV, or the companies, those who are installing the solar PV, if we ask this concept, just the concept, look, you have supplied the solar PV, you have installed it. What is the concept for achieving the safety? Is it with isolation or without isolation? If it is without isolation, what is the concept and how it works? Most often, the subject is unclear to the electrical engineer. Now imagine this part of this kind of an inverter, or this kind of, most of these inverters have communication facility, because now making a device with communication is quite easy. But if we ask them what is the basic principle behind the operation of your system, then the confusion starts. Most often they are unable to reply. Now you see, I'm just showing you a typical system. You have the DC solar PV, AC DC is converted here. Okay, two lines are missing. These are earthed. The green line denotes the earthing system. You have the positive, negative. So here dotted line means this is the TT system. This dotted line towards the neutral of the source is the TN system, and you have parallel load. Now, PEI should operate in connected mode as well as in islanding mode. Multiple PEIs may be connected. That means shared PEI. The first question is, where are you going to locate the switch KAC? Is it at the beginning of the installation or near to each and every inverters? If you put it near to each and every inverter, probably there you cannot operate multiple services at a time, because the entire system may be shut down. So the first challenge is where to place the relay KAC. The second challenge is amount of disconnection current. Imagine, I just draw an example. So technically these are connected here. I forgot to put the line. Okay, now imagine there is a fault in this place, DC side. The fault current will be returning in case of a TT system through the earth electrode. Then it is returning back through this route. And probably we are measuring the residual current at this particular location. This is one example. Now, TT system influences, the earth electrode influences the amount of the fault current, because it's TT system. In the other case, imagine the same fault. Here, there is a fault. The fault current is returning back, and we consider a TN system. The impedance of the system is quite less. The amount of current will be very high. So the system integrator as well as the DSO, distribution company, should understand this problem and explain, or they have to be in mutual discussion each other. Then only you can decide the amount of the current which the system should disconnect. So TNTT system actually influence the operation of the DSO. Mode of PEI, whether it is an individual mode or a collective mode, shared mode, all these things actually influences the question, what is the amount of disconnection current we are talking about? Type of KAC. This switch whether it is a 3-pole switch or a 4-pole switch, or the disconnection relay is a 3-pole or 4-pole. For example, if you think of a 3-pole relay, means the PEI is referenced through the neutral. Imagine the KAC is in off condition. So this is off. So the switch as shown in the figure, it is off. But since it is a 3-pole switch, the entire system here is referenced through the neutral display. So there is a fault return path. There is a reference in case of a 3-pole switch. Now, in case of 3-pole AC, imagine there is no power supply. So this switch is off. The system is running in islanding mode. Now there is a fault. Say, for example, positive to this one, there is a fault. There is a chance that this part of the electrical installation may be live. It can get live during a fault. So this is one of the problem. If you use 4-pole switch, instead, that means the neutral also you are disconnecting. In that condition, the entire prosumer installation will become like a IT network, means unearthed system. In an unearthed system, the challenges of fault monitoring and achieving safety, that is, the calculations are different and the entire requirement, technical requirements are different. So we end up with a different situation. Then type of RCD, let us say, for example, for fault protection or additional protection, if you are using RCD, of course, you need a type B RCD, because we are also talking about DC, we are also talking about solar PV without simple separation. So all these are questions which generally is very difficult to answer. Similar with respect to the overcurrent protection, the magnitude of overcurrent, the location of overcurrent protective devices are also important. For example, in this particular case, let us say in the condition number 1, the DSO is in connected mode and there is a fault in this particular location. The amount of fault current or the overcurrent, it depends. It is an addition of the current from all the sources. In the second case, the DSO is off. So the amount of fault current may be less because there are only 2 from the battery, and the solar PV are only pumping energy into this particular system. So basically, the amount of fault current as well as the where to put the overcurrent protective devices are a challenge. Safety challenge. So like this, if we discuss the system, there are several hundreds of safety challenges coming. I would like to explain only 1 or 2 simple cases. Safety challenge: system earthing, connected mode and in island mode. Now this table, you can see here, this is referenced from IEC 60364. This is the DSO, grid connected mode, AC side of the system supply. That means the distribution company is, for example, supplying TT system, TNS system, TNCS system. This is the AC type of earthing system in islanding mode. That means once when the AC is off, the power supply from the distribution company is off, what kind of options are there at the PI to operate? And now if you look at the third one, whether islanding mode is possible or not. Say, for example, if you have a TNCS system and during operation or during islanding mode, if the PEI is becoming TT, then you cannot operate it. Similarly, in case of TNS, making a TT PEI, it will not operate. Similarly, if you have a TT system, TT system from the DMO and a TT system at PEI, of course you can operate it, but fault protection is a challenge. So now in this particular case, you can see here system reference switching is required. So like this, each of these configuration have got certain advantage and more than advantage, lot of challenges are there. Combination of, this is the combination of different kind of systems. As you know, this is a complicated system. If I start explaining it will be quite complicated. Let me come quickly to the conclusion of the program. Now, this is an architecture of a PEI. Okay, let me skip this. I go to the next slide. Sorry. Yeah, this is operating in TT. That means the DSO. You see here, this is the distribution transformer. This is the origin of installation, and it is a TT system. Whereas this entire part, the prosumer electrical installation during islanding mode is made as a TNS system by making a switch here. You can see here, there is a switch. And what the switch does, it connects the neutral to the earth. And what is this item number 5? This is called as a system referencing conductor. So there is a localized system referencing conductor within the consumer premise. That means there has to be an automatic system which detects or which understand the type of system which is incoming, the type of requirements which are to be made in the prosumer installation need to be known to the electrical energy management system. And now the electrical energy management system, whenever there is a power cut, it is switching on the switch. As a result, the neutral within the consumer premise or prosumer premise is earthed. As a result, the integrity of the system is maintained within the prosumer electrical installation. Now, the basic fundamental here is, first of all, the engineers involved, multiple parties are involved here. The distribution system operator or the distribution company, and probably the equipment vendors of different or equipment suppliers of different kind of these systems and so on. First of all, there shall also the other parties like the owner of the installation, the contractor, the designer, several people are involved. First of all, everybody, every stakeholder in this or designing or installing a prosumer installation, they should understand what is the subject of system earthing. If you don't understand it, DSOs, or if you don't understand it, probably PEI will work, but it will not work in a safe condition, because what we are talking is safety. System earthing is classified into TNC, TNS, TNCS, TT, and IT. Also, I'm just taking you through the regulation number 16 of the CA regulation 2023, regulation number 17 of the CA regulation 2023, regulation number 18 of CA regulation 2023. Explain that the electricity supply from the DSO to a consumer premise shall be made as either as a TNS system or as a TNCS system. It means, if you look at the second picture here, transformer, the second system, it's a TNCS system. The transformer neutral is earthed. Throughout the distribution, the PEN conductor is also connected to earth electrode. At the consumer premise, you have a link between neutral terminal and the earth terminal. And then there is a separate earth electrode. So basically, this is the typical way of making a TNCS system with PME. You can find it in section 4 of IS 3043. Unfortunately, the distribution companies rarely follow this kind of system. For example, another regulation number 14, it says 43, it says that the neutral conductor shall also be earthed at one or more points along the distribution system or service line in addition to connection. That means on the distribution from the transformer to the consumer premise, the neutral also shall be earthed. Regulation 74 says a system up to 33 kV, for example, guarding. So once when the line crosses the railway line or road, there shall be a guarding, and there shall be a continuous earth wire which is connecting all the exposed and extraneous conductive parts connected back to the neutral of the transformer. All these things are there in the regulation. The challenge here is prosumer electrical installation. It's not simple like a consumer premise. In prosumer premise, there are different configurations, different methods are available to make them safe. As I said, if you wanted to operate in an unsafe situation, you don't need to bother about all these things. So you can plug it and work it, but the result will be accidents and fire. The first step as the improvement should be the distribution companies shall follow CEA regulations strictly. If this is not followed, of course, you will end up with danger. If not, they shall define the electric system which they follow. If any distribution company don't want to follow the CEA regulation, they have to define what system are they following. Accordingly, the connected PEI can decide the type of installation. The manufacturers and integrators shall be aware of different options to achieve safety. Why I put this point is I was interacting with several integrators, and if we ask this question, mostly the answer is not known. The challenges here are the knowledge, regulations are not followed, and the unknown system earthing. So with this presentation, I just gave you an idea of what subjects we are supposed to talk in future. Don't think that this is the whole introduction of prosumer electrical installation. The prosumer electrical installation, I would say it's a complicated subject. It is a good chance for institutions as well as a good chance for colleges to take up the subject as a part of their curriculum, because we are talking about safety, different systems, it can lead to unsafe situations. So let me see, Patnaik sir is already there. Sir, I have finished my presentation.
Okay, so good afternoon, everyone. And today, actually, you listened the exact concept of consumer and prosumer. First of all, the definition wise already explained very clearly. And second point, before to come to the basic question by the other delegates, I do ask a very fundamental question. Gopakumarji, we need to know, because basically people are of that not fundamental relating to the neutral and earthing. So please explain the basic way how to know and how to exactly to deal of a neutral and earthing, though you have already mentioned in terms of prosumer and consumer. So in a nutshell, please just enlighten the mass, the neutral and earthing.
Yeah. Sir, we are talking about, there are two systems, solidly earthed system and unearthed system. In solidly earthed system, we classify low voltage into T and TT. Unearthed system is IT, unearthed or earthed through a high impedance. That means the current carrying conductor of the electrical energy supply system is earthed. That means the neutral is earthed. Two methods, one is solidly earthed. Second is either unearthed or earthed through a high impedance. So T, the first letter, T or I. The second letter stands for, say for example, in a TN system. The first is about the transformer or the source, what we are going to do at the source. The second letter explains what we are going to do at the consumer premise. In case of TN system, all the metal parts of the consumer premise is connected back to the neutral of the transformer through a metallic conductor. That means there is a metal fault return path. The neutral of the transformer is connected. Let me try to show a simple picture so that it will be easy for the attendees to understand. I think, yeah, you need to give me 2 minutes. I'm sure I'm opening a file just to show what exactly we are talking. So what you are seeing on the screen, I hope the screen is visible, sir. The screen is visible, sir.
Yes, yes,
Kindly?
visible.
Yeah,
Yeah,
thank
visible.
you. So this is a TN system. TN system in the sense, the first is the transformer neutral. The star point is somehow connected to a reference. So this is T. Now, in the consumer premise, the entire metallic parts of the consumer premise is connected back to the neutral through a metallic conductor. And this is called as a TNS system. The third letter, S, stands for, okay, this is called as TNS. And here the S stands for a separate neutral and a separate protective conductor. The second system is called as TT. In a TT system, the source side remains same. The neutral of the transformer is connected to an earth electrode. But here the difference is the entire exposed extraneous conductive part of the consumer premise is connected to a separate earth electrode, electrically independent earth electrode. So this is how it is. So both are separated, TT. There is one more system which is called as IT. In case of IT, this connection do not exist. As a result, the neutral is completely insulated. Nowhere it is connected. That is IT. So these three kind of systems are there. Generally, the system followed in India by the distribution company is TT. Say, for example, at the transformer, neutral of the transformer is connected to an earth electrode in soil. And every consumer premise, the metallic part is connected to a separate earth electrode. So this is generally followed. But in case of a TT, additionally, what our distribution company does is, in case of overhead line, the neutral conductor is also connected to earth electrode at multiple places, which is wrong. So if you wanted to make a completely TT system, then you are not supposed to make this. You can go for example, this the earthing at the source, as well as the earthing at the these two. These two are allowed, not at the distribution. If you look at the regulation is asking to make a TN system, as I shown in the previous picture. TN system means something like this. The exposed and extraneous conductive parts at the consumer premise is connected back to the neutral of the transformer through a metallic conductor. Because the fault current will flow through this particular conductor, then you have an OCPD here to disconnect. Whereas in case of a TT, OCPDs will not work. We need to have an RCD. So the method of fault protection is different. Sir, I hope this is clear.
No, actually, let me to add also one or two points regarding this one. First of all, the listener, the attendees, those are listening. If I talk about the neutral is the common reference of an electrical system. And basically, whenever the three-phase system comes or any kind of a phases come, the common point which basically considered as the zero reference kind of things, that we call as the neutral. And the other earthing system, what it is been considered, there are two kind of earthing is there. One is called equipment earthing, another is called system earthing. And Gopakumar sir ne jo the kind of things what he explained, it is really a fantastic way he explained. Basically T and N system and TT and TN system and all. But the question is that the equipment earthing, you have to understand the metallic non-current carrying conductor part. If you are attempting to get it earth, that is called the equipment earthing. As you are finding also the body of the metallic enclosure, that is being considered as the earthing, and that is called the equipment earthing. System earthing, whenever it is of like a star connection system, common neutral point is that comes out as the in term of the name called neutral. And whenever to make all these arrangement and all, those are being considered in different pattern. But anyway, I think all listeners, they might have understood the kind of things, neutral and the earthing. Neutral is the common reference of the system, electrical system. And earthing is a common kind of a terminology which could be considered for electrical system to get it connected in the network, if I am correct.
Yeah,
I
so
think
actually there are some changes also. There are some changes now, which has come in the last 2 years. Earlier we used to call system earthing, which has been already removed or changed to energy systems type of electric system. That means no more system earthing. It is called as electric system. Similarly, neutral earthing has been modified as system referencing conductor or system reference earthing. So the entire, as you rightly said, the wording, neutral earthing has been changed to system reference earthing, or the wire neutral earth conductor is called as it can be called as system referencing conductor. And these changes had happened because of the implementation of the smart grid, the PEI, and so on. Over to you, sir.
Great. Actually, another point also we wanted to ask. Suppose at this point of time, one is getting connected in the system as the consumer. Let it be one entity is now continuing as the consumer. Tomorrow he plans for the prosumer. So will there be the earthing system or the kind of system what it is needed in the connection of inverter and all kind of things? So does the same thing what been considered during the time of consumer, should we continue on the same or should we go for any kind of modification or innovation or something kind of things?
Actually, what system earthing he is getting from the distribution company is the first question. Is it a TN system or TT system? This is the first question the prosumer is going to ask. Then the prosumer himself, there are different type of prosumer installation, individual, collective, or shared. Three types are there. Now, for if he is an individual customer, and if he knows that the system incoming system is a TT system, and then he can decide the kind of topology he has to follow to achieve safety. Similarly, if the system given by the distribution company is TNCS, then the topology within the consumer premise will be a little bit modified, and all these things will be done by the smart grid or by the automation system. The point is, the automation system should be programmed properly. For that, the fundamentals should be strong.
Yeah, great. So by this way, one more basic question I was asking as far as the safety is concerned. So could you just make it up for 2-3 lines? What exactly the prosumer to look after? I mean, what are those salient points in terms of safety consideration? Basically, 2 or 3 points, which are of a basic need. Because sometimes what happens, without understanding the basic of all these system earthing and electrical earthing and all, sometimes also some of the the general people also they do say that okay, if you keep multi number of earthing, then that's better because of a moment of a fault occurs means the current quickly to get dissipated to the ground, so the system will not have a much more current or the potential rise may not happen like that. So could you tell me 2-3 lines relating to that which consumer should have to give emphasis?
Sir, actually, earthing is only a term, it's only a name. I would say for the consumer premise, consumers have R phase, Y phase, B phase, and a neutral. And the fifth one is earth. Only the name is earth, it's a conductor. So all earthing means connecting the metallic, non-current carrying metallic parts to that conductor is earthing. Or we say, if you look at the IS 732, the definition of earthing is connection of exposed conductive parts to MET. That means a common bus bar is earthing. That means you have the fifth wire in a three-phase system. And the fifth wire, where it should go, it should interconnect every exposed and extraneous non-current carrying metal parts of the installation to a common bus bar. That is earthing. But what happens is, because of the name earthing, people think that it is something related to the soil, and they try to connect each piece of the building or each part of the electrical installation into earth electrode. which is wrong. I hope I answered, sir.
Yeah. You're absolutely correct. That's why I was just expecting that multi-point earthing is not important, and rather getting everything of a bonded and to get it connected to a particular point. That's the only choice you should have, because maximum way people they have the things in mind that multi number of points if you put, then the current will get the better chance to go out to the ground and dissipation will be better. Anyway, so the people those are listening, those are raising their hands. So you please allow them to ask the query.
Yes, if you have any questions, you can put on the Q&A box, as well as if you raise your hand, we can allow you to ask the question. But you should. Okay, there are some questions as well in the chat box. IEC 603648882. Yes. What is the reference to all diagrams used in the presentation? It is from IEC 60364. Any case studies on least single prosumer who is using smart meter? Yes, of course, but unfortunately not in India. Is there any prosumer in Tamil Nadu or state? Please share the data, customer demand, response detail. Norm. Sorry, I am unable to read the question. Sir, somebody had raised the question. Shall I?
Yeah. Please go ahead.
Mr. Davis, you can unmute yourself and speak, please. Mr. Davis?
I think you have to allow for unmute.
Yeah, I allowed. Mr. Davis, you can unmute yourself and put the question.
Okay, is it audible now?
Yeah.
Okay. Thank you, Gopal sir. I think it was an excellent presentation, and the questions asked by Mr. Patnaik sir also is very. See, only thing what has happened, I am into this field of electrical engineering for a quite long time, more than 35 years. But now with the solar system, when I understand this, it seems to be a bit complicated system with respect to safety. Now, what is the data it shows? As of now, there are a lot of solar system, and what is the accident data it shows compared to other systems? Because a normal engineer, it is difficult to understand and implement, because I am not able to follow, so I can imagine, because I am also a trainer, I know what is the market, what are the engineers, what they do it. So can you give a small tip on this? What is the...
There are a lot of accidents, or a lot of incidents are happening.
Okay.
With respect to shock as well as fire. Fire, in fact, if it starts, especially if the fire starts on the DC side, then you cannot stop it. You have to wait until the whole thing burns down.
Okay, because one of the incident investigation I was involved, where that when the feeding happens and then the circuit breaker, the main end, it was not got disconnected, and then there was a flashover in the 6.6 kV breaker itself. So I don't know how it has happened. So now I am finding it, of course, is a very complicated system. Thank you, sir.
Actually, if you look at the protective devices in the DC side, the protective device on the DC side of the solar PV, those devices are just like isolator. They will not disconnect in case of any short circuit or in case of a fault, because the amount of short circuit current itself is quite low. So,
but this fault, okay.
Yeah, that is the reason. These different methods of identifying fault and different methods of disconnecting the system has been implemented. Now, a conventional system will not work on the DC side, especially solar PV. Number two, in case of any arcing on the DC, you cannot stop it. It keep on arcing, and it will burn the whole system.
Okay, that means this IS 732 is applicable here also, right?
Of course, yes.
Then the disconnecting time and then the potential rise, all these are okay.
All are applicable. Only thing is the method of achieving the disconnection is different. It is not like you put a device and the device trips. That will not happen.
Okay. Thank you, sir. It's a quite interesting topic. So I will get into more into this and then interact with you. Thank you very much.
So, Patnaik sir, can we stop for the day?
Yeah. If no more queries are there from any corner, then we can stop it over here. Probably if anyone else, then please check it out because I'm not able to see anyone on the way of raising the hand.
Yeah. I think there is no further
No,
question because this
Smriti.
subject itself is a dry subject.
I think someone has raised, might be Smriti. Please allow him.
Yeah.
Yes, sir. Namaskar, sir.
Yes,
Sir,
namaskar.
actually,
Yeah,
Ms.
namaskar.
Smriti.
sir, actually in an apartment, we have distribution substations and the panel room is connected through using cable, and it is a TT system. Can we convert this to TNS system by using the armor of the UG cable?
I cannot answer it because I don't know how their reliability of the armoring and how the reliability of this blanding and all. IS 3043 is not allowing armoring to be used as fault return path.
So, sir, we have to install a permanent earth conductor, separate
It is
earth
the best
conductor.
way. Yes.
Sir. Okay, sir. Thank you, sir.
Thank you. Okay.
Actually, I'm going to add also, Smriti, I want to add also one more point. And basically,
Yes, sir.
the kind of earthing conductor, basically where the current returns out. Initial days, we were having of the earthing conductor of a particular specifications and all. In present days, there are fault happening is also in a different way because those are of not, I can say, disciplined faults. They are all nuisance indisciplined faults. That means containing of harmonic currents and all. So the quantum of current, what basically expected, is becoming more as compared to the means the previous wherever it was of having of resistive loads and all. So that's why wherever you are thinking and whenever you are thinking about the earth to get it written and to have the fault current to pass, I hope Gopakumarji to make one point also here regarding the specification of earthing. You should have to also educate the people, those are on the way of practitioners and all, to go for the specification of earthing. So 1 or 2 lines, please.
Yeah, so it is actually the best way is to make a TNS system or TNCS system. That means there is a separate neutral and separate protective conductor. So fault return will happen through the metallic fault return path. The best way is, as Mr. Smriti asked, from the consumer premise to the transformer neutral point, there has to be a metallic fault return path, maybe a fifth conductor. You can also use the fourth conductor, that means neutral, but then it need a lot of discussion, lot of we have to discuss and do it. Metallic fault return path only will ensure that the OCPDs are tripping within the time. That is very important.
Correct. And another point also, techno-economical is also a factor because at the present point of time, the kind of fault occurrences and the acquaintance of the users and all, they do not bother about the things. They do not foresee also the things how it will happen and how it will just disturb the system. That's why they go for the economical way, not to have those TNCS system and all. So probably it's time to go for educating the people to go for the best kind of things where even the fault occurrences also will be taken care.
Yeah.
If the recommendation goes in that way.
Yeah. Also, on Mr. KK Singh has requested. Mr. Singh, you can unmute yourself and ask the question. So, sir, I think that's all. We are done.
Yeah. So thank you, Gopakumarji, because it was really one of the best. I think the disclosure what you explained today. And there is a lot of things. Sometimes also people do not get the things to explain or to get it acquaintance of this one. And there is need of the way. And hope so also I'll be requesting all the listeners. This Cap Electric Private Limited, they have written number of awareness books. And one of the best book is that the missed link. So that if it is to be available, anyone wants, and Gopa Kumarji being the MD of DKF India Private Limited, he can help it out to get available of that one. So you get connected with the KEP Electrical Private Limited, and just to know the new upcoming things, what it is coming up. And another point also, as most of our the Spark members are there, and in each and every session, we are planning to have the best things to be expressed. And the next time also, we may have some of the academician professor also will be there. At least we must be getting to know regarding the theories, theoretical aspects. And practitioners wise, we have already 3 sessions we concluded. So next time we can have also the academician kind of things. If it happens, we are planning to get it in that way. Hope so also today's session was of really interesting. So we do expect all the people to get it connected. Any kind of queries are there, you can even ask also in our Spark group, so that Gopa Kumarji is there also in many of the things, and we can get it connected.